Greetings. In this video lecture, I'm going to discuss about the meaning of constant and variable, two elementary and basic concepts in mathematics that unfortunately quite few students, freshman students taking basic algebra and developmental mathematics, they are really not comfortable with them. Now, I will be presenting this lecture from ground zero, K through 8, let's say, but the developmental and basic algebra student can also benefit from that. Okay, then let's get started, shall we? Let's start, as I said, from ground zero. Let's start to see what number is. What is number? Now, when I say in the English grammar or in conversation, when we say good man, good is what? Is an adjective describing the attribute of man. Is that right? In contrast, when we say 5 apples, 5 is also kind of adjective, but it does not give the attribute of apple, the quality of apple, but he gives what? He gives the quantity of apple. So again, 5 is like adjective, but describes the quantity, not what, not the attribute and quality of the apple. Of course, we can use it as a quality, but that is beside the subject, as a number we are talking about. Okay, now let me see what I have here. Now let's see what the numbers that we use. Let me put that here. Now I have written them large enough so that I don't have to go back and forth to zoom in and out. Now 0, 1, 2, 3, 4 and so on and so forth, we call them digits. They are called numeral. They are symbols representing numbers. Symbols representing numbers. In contrast, we also use letters of alphabet like X, Y, Z, A, B, so on and so forth as what? Representing number, standing for numbers. So then what is the difference between these two? Both of them are symbols, dummy symbols. What is the difference? The difference is that in case of numeral, this symbol standing for the number, they have pre-assigned values. I repeat myself, they are pre-assigned values. So when we say, for example, 7, what the assign of that we know is talking about a 7 what? Quantity, 7 quantity. We know what is assigned, what the 7 stands for. But in case of the X and Y, letters of alphabet representing number also, they are not pre-assigned. They are the values that we assign to them. So you see the difference. Both of them are what? Standing for numbers. Now, let me just make one. I didn't put it in writing. Maybe I could put it here on writing for you. And hopefully I will write it large enough. You see, number, for example, this as a tally mark. This is 2 tally mark, is that right? That's what stands for 2 tally mark, historically. Now then you become a little bit fast, quick, and you do it like that. Look, that is what our 2 come from. And then of course the artist comes and make it nice looking and make it like that. The very same is true with 3. 3 is what? 3 tally marks. Huh? Now you become quick and fast, you do it like that. That stands for 3. And as a matter of fact, the very same goes with Hindu-Arabic, because Arabic, we don't use this symbol for numbers. For 2 is again 2 tally mark, but they are not like that. And then again, you want to write it fast, quick, becomes like that. So this is 2 in Arabic, Hindu-Arabic. It stands for number 2. And same is true for 3. 1, 2, 3 tally marks, and then you become quick and fast and you don't want to do this, you say, okay, 3. And of course there are historical background where the 4, 5 and so on comes, but that is beside the subject. Okay, now, I guess I don't need this one. Now let's see, I have written this one for you, by the way, if you want to write it, because some students, they like to write that. I said, in case of numeral, a unique value has been assigned to each of the symbols, 1, 2, 3, and so forth. And that, but this is not the case for what? For the letters of alphabet representing numbers. I already mentioned this is kind of repetition. Okay. Now let's see what I have next. Next I have 3 algebraic equations. All right, 3 algebraic equations. X equals to k, y equals to x plus k, and x squared plus y squared equals to k. Now I tell you about but in this case, let's say k is a constant. So if k is a constant, that equality indicates that x will be constant. And what is constant? Constant is number 7, for example. The value does not change. It still remains same. 7 does not assume any other value. We cannot say let 7 to be 8 or let 7 to be 6. So when I say k is constant, then x will also be constant in that case. So the letter x that we are used to it and consider it as a variable depends on the context. X can also represent a constant value. Now notice that I didn't say anything about y. In this case, when I say y equals x plus k, where let's say k is constant and x is variable, let's say, then y will be variable. Is that right? Because we have a variable for constant. Constant value does not change. Is, for example, is 7. 7 stays same for the entire argument, but x can assume different values. And the different values that x can assume usually comes from its domain. And domain, as you are already some of you familiar with, is what? Is the set of all permissible values that the independent variable can possess. That is the domain of what we are talking. So depending on the domain of the x, then x can assume any values that comes from its domain. Then y will also become a variable, because if x is variable, x is equal to y. The k is the constant. So if x is variable, y will be variable. So then what is the difference? The difference is that here we assume we give numbers from the domain of x to x. So we are selecting, but the y value changes, but with respect to the values that we have already assigned for x. In other words, y is not independent, but x in a sense is independent. We just assign value for that, can assume any value we give to it. All right then. Now let's talk about x squared plus y squared equals to k. Let's see, I have talked about that. Let's I have another one. Let me just what I just said, I put it off and I'll go over that again. Here, when I say y equals to k, I already say k is what? Constant. So if k is constant, the equality indicates that y can also be constant. So y sometimes stands for variable, so y sometimes stands for constant. That is what with the context we can say which one is which and which one we are talking about. So if k is a constant, it's naturally to think of that y will be constant. And we know the graph of that, I'm not going through that. Okay, now let's see, I have this one I already mentioned. And let's talk about x squared plus y squared equals to k. Now here, x squared plus y squared equals to k, where k is a constant, x and y are variables. Now, I already mentioned that. Now, k, the constant term here, it governs what kind of values x and y can possess. What kind of values will be the domain of the x and y. Do you follow me? So let me make an example. For instance, k is 4. When I say k is 4, then k does not change. Remains 4 for the entire argument. And what is the argument? What kind of number is the domain of x? What kind of number will be in the domain of y? The domain of x cannot be a number bigger than 2 or less than -2. And same is true with y. The domain of that cannot be less than -2 or greater than 2. Now, k is the one who determines that. For example, in this case, when k is 4, let's say x is half, then half square is 1/4. Therefore, y should be a square root of 3 over 2, because the square of that will be 3/4. 3/4 and 1/4, excuse me, in that case, if it is, let me see, if x, I said x equal to what? 1/2. 3/4 and 1/4 is what? Is 1, and that is in case if k is 1. Now, suppose k is, for example, 9. If k is 9, the domain of x will be between 3 and -3, including 3 and -3. And the domain of y also will be between 3 and -3. So k will keep x and y in orbit. Now the question is, the good question to ask is that, what about if k is not constant? What then? Think about it, and it's a good question to ask. But the answer of that is way ahead of you. The answer of that comes in calculus. Usually second semester calculus, and some schools will be the third semester calculus. They go to multivariable calculus, and that will discuss this kind of function, f of x, y equal to that. So that means k is no longer constant. But as long as it's constant, those of you who are already familiar with, the graph of that will be a circle with a radius of a square root of k. And I say k is constant. Constant can be 0, negative, or positive, but it is very obvious that k cannot be what? Cannot be negative, because left side of the equation can never be negative. X squared is always positive, y squared is always, non-negative, y squared is always non-negative. The summation of two non-negative is non-negative. Therefore, the left-hand side of the equation is always non-negative. Therefore, the right-hand side must follow, must be non-negative. So we know what kind of number k can be. Okay then, now in closing, I would like to say a few words about negative x. That is really going to be a kind of subject that comes in the next video I intend to do about the subject of absolute value. Now here, I say x is a number, all right? Then what kind of number is negative x? Then you say negative x can be negative, can be positive, can be 0. Now if somebody asks you what kind of number is negative x, where x is a number, the good answer to give is, I don't know. You tell me what x is, then I can tell you what will be negative x. So okay, I tell you x is pi. Then you say negative x will be negative pi. Then I say, okay, x is negative 7. Then you say negative x will be positive 7. Because negative will make it positive. But this is not the way mathematics works. When somebody asks what kind of number is negative x in mathematics, mathematics takes all the possibilities under consideration, put them into conditional statement, if then a statement, and then answer the question. This is what mathematics does. So he doesn't tell me what x is, I can tell you what negative x is. So he says, he put conditional statement. He says if x is a positive number, then negative x will be a negative number. If x is 0, then the bullet of negative is not going to hurt it, remains 0. And if x is a negative number, then what? Then negative x will be positive number. Again, I repeat myself, when you ask such a question, mathematics takes all the possibilities of the consideration, put them into conditional statement of if, then he answers your question. Now, this negative x that I brought it up, in fact, is kind of very fundamental, and if you really fully comprehend that one, the concept of absolute value should not be giving you difficulty. But unfortunately, many students, including college algebra and the pre-calculus students, have difficulty with subject of absolute value and the related problems. But in reality, that is what it is in reality. So the next topic of the lecture will be about absolute value, and I'm going to go more in detail of the subject, and hopefully once and for all you overcome that. Okay, then I thank you for watching, and I hope this lecture was beneficial. I wish you all prosperity, and so long.